we had some scheduling problems, and not many people got to know that the class was scheduled for 2 o'clock today. I used the Blackboard to announce that it will be at 1 o'clock, but only 2 people showed up for the 1 o'clock session, and 4 people shows up for the 2 o'clock session. So it's a bit of a mess. So because the game programming has been moved already, maybe we move that session to Tuesdays, and we just meet at 9 o'clock every Tuesday. Those people who cannot make it, then they will kind of participate like online or after the session. Yeah. It has changed?
Look, it appears it's 9, 10:30.
Yes, exactly. So it is twice. Right.
Is it going to be like that every week?
No. So
so we can schedule it.
Yeah. So what I'm saying is, let's have meetings on every Tuesday at 9, and that will be a regular time slot, regular session, and there will be no more confusions. Otherwise, if we let it, the schedule decide, the schedules change. Like that one was changed, overnight. So nobody knew about it, like including me. Like if you didn't, emailed me, I wouldn't know actually. I thought we will have a session on Thursday because that's what I checked last week. And last week, the session was scheduled on Thursday. Yeah. So, okay. So from now on, let's do it Tuesday morning, 9 o'clock before the game session.
Which room though? Because the game session doesn't have a room and the one in mobile is in A061.
Yeah.
Which is downstairs.
Downstairs somewhere.
Yeah. So let's meet in the game lab. But you don't have access to game lab. So
no,
yeah. So I will remind Simon to make sure that the game lab access is open for all Max students.
Yeah, if he's up there, I'll talk to him after this class.
Yeah.
Just to remind him about the gaming as well.
Yeah, perfect. Okay. So that's the logistics. Now, if we go into the Blackboard, how many of you issued the? Okay. No one, right? I mean, I checked yesterday, and I was hoping, some things will happen before the class. But if I check it again now, let's see. Nothing. All right, so what is the problem? Is the problem that you undecided, or is the problem that you don't know what to do, or what is causing you not to write your paragraph? Or you don't want to?
I forgot I sent you through email my
Okay.
proposal.
Yeah, you did.
For me, as I told you last session, I already know what I want to do, but I don't know why I can't manage to put it on paper and to write my ideas.
Yeah. So it is not uncommon for having that difficulty, right? You have in your head what you want to do, and you are doing. Even sometimes you already know what you've done, like when you're writing your thesis, and then you sit and it's like really hard to turn it into a written document. Yeah. But it needs to be done. It will need to be done for the thesis, and it needs to be done for the proposals and for drafting the notes. And we need to learn how to formulate our thoughts in a written form. There are, and generally speaking, there are two types of people, how they think. So there are, of course, that it doesn't work exactly that way, but we can generalize saying there are people who think in kind of sentence-like structures. So they make kind of a language-based inference in their heads about some of the situations. So you may say, oh yeah, like you don't say it aloud, you like think it in your head, like, should I go to the cinema tonight? Yeah, maybe it's raining outside and I have nothing else to do. So you decide to go to cinema. And you kind of have this kind of a narrative going on in your head. Those people tend to be easier to write because the way of thinking is kind of based on language. And there are visual thinkers which don't have the language happening in their heads. They just see images and it just happens, right? And I'm more like that person myself. So then if someone asks me, what you're thinking about, it's like, whoa, it's like so hard for me to say because I have to turn those images into words. If you are the more verbal, sentence person, and someone asks you, what are you thinking about? You say, yeah, I'm thinking whether to go to cinema, right? Because that's what I was thinking, right? It's so easy, like, to answer that question. So if you have people like more visual, they have more hard time formulating the sentences and formulating their thoughts on paper. But, well, it's a skill. You can learn it, right? So you can learn to do that. And it is, so the visual thinking people, they have certain intuitions of what and how things should be solved. But they have often hard time explaining why, right? So, like, sometimes I see a piece of code and I will refactor it because I feel, that it's more beautiful the way I've done it, right? But, sometimes it works fine. Sometimes you need a reason why you are doing certain things certain way, right? So you have to explain why your way of doing it is better than the original way, or why this refactoring was useful, right? And you have to explain it to your coworker or to somebody. And the only way we can do that outside of art is through, spoken or written communication. So we have to say, well, I've done it like this because it follows the naming conventions, or because it's more consistent with what is up here, and because it's more succinct, or maybe because the if statement is less branchy. You have to come up with all those reasons. And originally you may just know, like, intuitively what's better. But when you formulate it, then it becomes kind of obvious and clear, and it's easier to explain to somebody, right? So those two ways of working are kind of useful. Both are useful, and the visual thinkers have to learn how to do the verbal and kind of language-based formulations. That is potentially one reason. And the only way to overcome it is actually to write, right? To write some of the sentences and formulations and so on. Like my supervisor before, during my master's, he didn't want me to ask questions like in the meeting. He wanted me to write all the questions in the email before the meeting. And that turned out to be quite hard, right? Because you actually have to think of what it is that you need to ask. And by thinking about it, you often find the answers yourself. You often actually know that whatever you are thinking of is actually not correct, because you should be thinking about it this way. So even this simple exercise of turning your questions into written sentences is already useful. Okay, so what I was thinking of doing today was discussing, because in the paragraph which you're supposed to write, you don't have to write any questions. You're supposed to just describe what is the area, what you will be doing. The next step is we have to make it a little bit more concise, a little bit more focused, and we have to formulate research questions, right? So I was kind of hoping that we will work with some sort of material and kind of try to get to the next formulation, which is more focused and better from the scientific point of view. Okay, so yeah, we don't have any anything kind of written, so we have to.
If you update it, there's one more.
What's that? There is one now.
It should be.
Right. So in general, what do you think kind of a good research question is like? How would you distinguish a good research question from not a good research question? So before we answer this, let's step back and let's imagine that we want to draw some parallels. So who is building bridges? How the bridges are constructed?
You mean in what order or?
No, in general, like, you know, a bridge over the river. How does it happen?
It goes first build the pillars.
Yeah. So who is planning it?
Of course, you have the
Civil
the
engineer.
Civil engineer.
Civil engineer will plan and make kind of planning decisions of what needs to be set up, right? And then some, you know, construction team will construct it, right? So the construction team doesn't necessarily plan what to construct; they just build it, right? The civil engineer will plan how it will be built. So how the civil engineer knows how to plan this?
But maybe even before you have kind of a designer, and
Yep.
then the civil engineer are there to ensure that what the designer decided is physically realizable.
Sure. Yes, very good point. So let's say we skip the designer for now, we simplify it, and we just use the civil engineer with whatever rudimentary design he comes up with, right? So what is the civil engineer using to construct the plan? Knowledge from where? From whom? From what?
Back from the university.
Right. So the civil engineer knows. Yeah. So what does the civil engineer needs to know? He needs or she needs to know how to calculate things. She needs to know how to use the specs for some materials, and she needs to know some, you know, physics laws.
A lot of physics.
Right? Okay. So how do we know the physics and how do we know the material properties? Is the civil engineer discovering or learning about it, or it's someone else's job? Typically.
Depends analyst.
Yeah.
Yeah, maybe he or she has a team around him, and yeah, in that team there is an analyst that will, ensure everything about the physics.
Yeah.
And maybe it's also part of his job, the civil engineer himself.
Exactly. So
Yeah.
physics in its own right is a field, right? So we have scientists doing the physics studies and they come up with some laws and some formulas, right? We have chemists which do the same for some of the chemistry and materials, and we have material scientists which investigate properties of, you know, metal beams and so on, right? And then the civil engineer doesn't need to do all of that because he or she will use the knowledge which kind of is there to calculate some of the properties. So if the civil engineer decided to have like a bridge with some pillars, he or she can calculate the forces and calculate what tensions it would have and what properties of the materials used are, so it will actually work, right? So whether, let's say, wooden pillars would be sufficient or whether you have to have concrete or reinforced pillars, whatever, right? So we have this kind of engineering task of constructing the bridge, and we have the scientific work which goes before that about the materials, about the laws of physics, and about all these properties that the engineer will use. Will the civil engineer need to do any research?
Yeah, not about physics. We're gonna have to do some research, but about, for example, previous works.
Yeah.
The environment is building in.
Yeah.
Also, yeah.
Previous works in the good and the bad examples, so you can know what not to do.
Yeah.
What to
Yeah.
do.
Yeah. So what you're referring to is kind of a research in quotes, like a common, term which we use for kind of checking out what has been done before, right? So I say, I have to buy myself a new phone. I need to do a bit of a research what to buy.
Yeah.
I have to check what's available on the market, what the prices are, and so on and so forth. But is it like truly research in a scientific form, or is it just a kind of a common layman type of research? It's more this kind of common layman, right? So civil engineer, of course, they need to know what failed, what type of bridges failed before, what kind of constructions were successful, not successful, what are the environmental factors, is there a lot of salt in the air because the bridge is close to the sea, or are we inside the country, there is no salt, there will be less corrosion and so on. So they need to kind of investigate a lot of factors, but they kind of do that for the purpose of the task at hand, and the outcome is not something that is necessarily valuable to a broader community, right? So if I say I'm doing a bit of research of what phone to buy, and I spend, I don't know, 4 hours of doing research on the internet, checking what should I buy, and then I finished, I know what I should buy, but is that knowledge very useful for anybody else? Usually not. I mean, because I'm using a lot of personal factors of deciding what I really like, right? However, if I did a review over, I don't know, price distribution over different countries and so on of the phones, it's kind of a more generic piece of knowledge that might be useful to others from social context or something like this, right? So there is no really clear distinction of the kind of common usage of term research and this kind of more scientific use of the term research, but there is one distinguishing feature which distinguishes this kind of a common usage from the proper scientific usage. What is that? So one, we have two cases. In one case, I'm doing research in quotes, checking out what should I buy for myself. And I spent a couple of hours or couple of days investigating, the world. And then at the end of the process, I have some knowledge, which now I can say publish, and potentially it might be useful for others, right? And now we do that twice. And in one parallel universe, that piece of knowledge or that piece of research is scientific, and in the other one, it isn't. Why in one we would say it's scientific and in the other it isn't? In both cases, it is something kind of potentially useful for people and published. I actually wrote a document describing it. So what would distinguish the scientific from the non-scientific? What would be the criteria to distinguish those two?
But it's personal notes for starters.
Yeah.
The research question.
Yeah. Can you be more precise?
Maybe it solves like a common problem.
Yeah, how general it is. Yes, all are good, but not good enough.
Something new.
New, yeah, that's good too. Still not good enough to clearly distinguish this from this. So let's say I've done something that is quite general, useful for many people. What was your criteria?
Non-personal.
Yeah, and it's kind of generic that, I didn't included a lot of personal criteria into formulating it. It's still not scientific. What would make it scientific? Methodology, exactly. So the methodology will make it scientific or not, right? And the methodology involves like verifiability. So if I say this phone is better than this, okay? And I said because of those assumptions and those criteria that I use and because of those results I get, you can repeat my experiments, you can repeat those measurements, and you can repeat everything. And if you agree with the assumptions, you will come to the same conclusions. Whereas if you say, well, Apple is better than Google because Apple is more designer friendly and it's like fancy and it's, very nice, and Google isn't, it's hard to use. It's very subjective, and we cannot really falsify it. We cannot say you're wrong because here you know, whatever reason, right?
Yeah.
So if something is not falsifiable, typically that means it's not really scientific. And if something doesn't follow the kind of methodical research methodology, usually it is not scientific neither. Even though on the surface, those two reports may look the same, right? There is a lot of market research, and research in quotes, and there is a lot of reports and a lot of white papers and so on, which are not properly scientific. They just based on personal opinions. And sure, they have value.
Those are essays.
Essays as well. I mean, we do have those too. We try to make them scientific, but some of them end up being kind of a personal opinions. And the point is not to have them. The point is to be able to distinguish, right? So what are scientific results useful for?
To give validity,
Yeah.
reliability,
Yes.
to the research.
So let's start with the other one. What are the personal opinions useful for? So, you know,
To make a decision.
Enhance the argument.
yeah, to see point of view, to see somebody else's opinion, to sort of look at the problem from a particular angle, to, you know, have a discussion about something.
Try to convince someone.
To convince someone about something. They are not very good to build bridges, though, right? If you say, oh, you should use this wooden, you know, pylon for this bridge. Yeah, maybe, but, you know, maybe I shouldn't use your personal opinion what pylon I should use. Maybe I should use like scientific evidence that this pylon will actually sustain the forces that I will have on this bridge and it will actually work, right? So personal opinions are kind of useful for some things, to point us to certain direction, to point us to certain way of thinking about the problem, but they are not very useful to construct something, to kind of build further research or further artifacts on top of, because they are just personal opinions. Whereas the scientific results are useful for constructing things, for building things, for like learning about the real world, not the opinions, but the world itself. So we all will always have both. It's just that we should be able to distinguish which one is which. And as scientists, we should strive to get the scientific outcomes priority, right? So when we're writing a thesis, when we're writing an essay, when we're writing an argument, we're trying to build an evidence and make something on the scientific side. So what's the difference between an opinion and an argument?
The arguments should be based on concrete facts.
Yep.
On evidence. Actually.
Exactly. An opinion
An opinion is-
doesn't have to be, right?
Yes.
Opinion can be just an opinion. Again, you should make sure that in your arguments, I mean, in your reports or essays or theses, you're trying to have arguments, not opinions, right? It's very hard to completely get rid of opinions, and you will have opinions in whatever you write, because it's super hard to get rid of all the opinions. For example, you often say, in recent years, there is a growth of mobile computing, right? That's an opinion, right?
Where's the evidence of that?
But a lot of papers start like that, right? To take any scientific article, and there is a lot of statements like this, right? It's an opinion, right? But you can see something like this. According to the studies, and then you have some references, the number of mobile users growth, it looks like this curve, right? And okay, that is not an opinion. That's kind of a result. That's a measurements which somebody did on the real world. stuff, and you have evidence that what you're saying is backed up by the reality, right? You may, based on this fact, build some argument that there is a growth in recent years, but you would have to compare the growth in recent years to growth in not recent years, right? And so on. So, well, usually what happens is you write something and then you kind of step back from it and you read it and you kind of try to iterate over it and change it to be more solid, more scientific, more objective, and more an argument than an opinion, right? But you have to start somewhere, and as I said, starting with opinions is okay. We all have opinions, and we can start with them. We can say, I think this kind of mobile devices will diminish the something, right? It's an opinion. You may find an evidence to either reject it or accept it, right? So you may formulate an opinion in a form of hypothesis, or you may just start with an opinion and then try to investigate what makes your opinion the way it is, right? So you may try to find some evidence and so on. How to do that? Iterations, right? Start with something written, and then iterate over it. We did some of those things last semester. I mean, last year, we had some write-ups happening early and then later on. And I mean, the later essays and later feedback you were giving to other students was better, right? You were improving the way you were formulating the arguments and building the arguments by practicing it. Here we just have one shot, kind of. We try to split it into to work with Blackboard a little bit, so we will kind of iterate, but you are just kind of working towards a single report, right? So what you need to pay attention to? First thing is research questions. So then we go back to the original question. What will make a research question a good question, and what will make it not so good? What do you think? Specific, yeah. So specificity can be a metric which you can validate some of the questions. Like if you have two, you can say this one is more specific than this, right? There is not really good or bad, right? Sometimes general questions are pretty good. Sometimes a very specific question is good. It depends on what is that you need to know. If the question is too narrow, let's say we had a student who was working on Kinect 1 to see how accurately Kinect 1 can distinguish the depth differences between objects, right? And then Microsoft updated the driver, for example, right? Yeah, so the question was very, very specific. And then the answer was irrelevant like a couple of months later when the driver was updated or where the hardware was updated, right? So sometimes the very narrow specific question is not the right way to go because it has a limited value, limited like usefulness. Then again, some broad questions will lead nowhere because they are too complex and too complicated to actually have meaningful answers, right? There was an interesting study on so there was an interesting study on the sleeping patterns and in US, and the researchers asked a question: are white people sleeping more or less than black people, right?
Of course they asked that.
Yeah. So then they took some samples and they took, African American statistics of how long they sleep, and they took some similar sample size from the white population, and they published, well, on average, the white people sleep like 1 hour more than the black population, right?
So I didn't go to Africa to get.
No. They were doing it in US, right? In a similar neighborhood, similar city, right?
But that's assuming a lot. Like if it happens in the US, it happens worldwide.
So there is many wrong things with this study, right? So first of all is, okay. So let's not talk about all the wrong things. Let's just talk about one wrong thing. The one wrong thing with the study is that a little bit later on, somebody repeated the studies and they got a completely opposite results. They said that in their results, it turned out that black people are sleeping 1 hour more than white people, right?
Yeah, because they didn't know the other country, or
Not reliable.
I mean, the different city, different sample, right?
So basically, this question is valid or not?
Yes. So, you know, it is a very complex issue, sleep, right? And the link between sleeping patterns and the color of your skin is so remotely connected that probably there is no correlational or causal link at all, right? It's just random. So it just happens that sometimes in your random population, one set is a little bit bigger than the other one, right? So this research was kind of nonsensical in a sense, right? This research question is like,
The BuzzFeed question.
yeah, it's not good one. But as a side effect, what they discovered is like, because a lot of research teams did similar studies, right? And what they discovered, they kind of built a sample of different dark skin population sleeping pattern and the whites, right? And they discovered that from all the research people were doing, the two data sets were different. The white data set was having much smaller variance than the dark skin people. So the dark skin people, like, they form a population which sleeps like, you know, on the spectrum, you know, bell curve, but the bell curve is more stretched and the whites is a little bit more narrow, right? So and that's why the results of the study were always kind of random, because sometimes you get those black people who sleep less and sometimes you get those black people who sleep more, and they have kind of extremes, whereas the whites don't have a lot of extremes, right? And this result is kind of interesting. Like, why would that be the case, right? Why would that be the case that the whites are more homomorphic and the blacks are more widely distributed? Because, you know, normally what you would hypothesize is that they kind of should be the same, right? I mean, there is no probably biological reasons why one should sleep more or less than the other, and at the same time, why one is so spread and the other is more homomorphic, right? So, you know, we don't know, but again, this would be kind of a research question which would be reasonably okay for investigating why the research methodology is flawed, right? Because if we always getting kind of a very big variance for blacks and very small for white, we're doing something wrong, like we're sampling somehow wrongly their populations, presumably, right? So maybe it's worth investigating what we're doing wrong. And if we cannot find what we're doing wrong, why are we getting this kind of difference, right? Because you would sort of expect to be the same. Okay, so specificity. What else you could use as a metric for a good research question?
Comprehensive. Brief.
How succinct it is?
Precise and concise.
Yeah.
I know that word. But
Yeah.
I think it's
whether it can be proven or disproven.
Exactly. So it has to be falsifiable. Like, you can, you know, falsify it, but you also need an answer, right? And that's more that's the criteria which comes first. So your question needs to be answerable, right? If you have a question which we cannot find the answer, or it's, you know, is there God? Well, you know, First of all, it's really hard to find out the answer, and second of all, it's really hard to falsify once you find out the answer, right? So being able to find the answer based on argument, not based on opinion, right? So is there God? Well, we can kind of say, okay, let's ask everybody on Earth what they think, and let's make majority win, right?
Yeah.
If majority people say it exists, we kind of postulate it exists, right?
That's because the majority is Christian, Muslim, or Jewish.
Yeah, exactly. I mean, majority of people are non-atheists, so probably they say God exists. Therefore, we postulate God exists. You know, can we falsify it? Well, not really, because our answer is based on opinion, not argument, right? Yeah. So being able to answer it based on argument is the primary one. And then because of the argument, we can, by definition, falsify it, because if we pinpoint some problems with the argument or pinpoint some problems with the assumptions we're making to make the argument, we can kind of effectively falsify it. Or, you know, you may find some evidence which supports your claim, but then that evidence may turn out to be not correct or something, right? So how specific or general it is, how well formulated it is, and whether we can answer it or not based on the argument are already quite a good criteria, right? So when you're formulating your research questions for your report, you keep those in mind, right? It's not that you know, so we can sit in the chair and kind of kick back and say, well, you know, I would like to do some research with this gaming thing, and I kind of just come out with a really good research question out of the blue, right? It doesn't happen like that. You know, this Newton sitting under the tree and apple falling on his head, and he asking why the apple falls down, right? Kind of thing. Well, it does happen occasionally. Occasionally, you may have some insight, and you may ask a kind of a right question on the right level with right specificity and so on, but it's rather hard. So what we do instead, we check within the domain what questions have been asked before and how they were answered, and what questions were kind of good questions and what questions were a little bit vague or kind of ill-formulated. And that creates an environment in which we can then formulate further questions or additional questions to kind of get more insight in the domain itself, right? So first, what you do, you read, right? So you read what's been done before, what people were researching, how it was done, what methodology they used, how they built the argument. And it sounds really simple. You just find the papers and read them, but it turns out that it's already pretty complicated. First of all, a lot of papers are kind of bad papers. A lot of them have mistakes in the methodologies. They are using a lot of opinions, and sometimes they don't even have a research question. Like they kind of ramble about something, and they don't, you know, really properly answer something. They usually say it depends, right? And then those papers are kind of useful, but they're not good to start with. They kind of on the gray area of what we already know and what we don't know yet. What you really need to start is what we already know. You need to get kind of a crisp line of where the state of the art is, what is known so far. So you want papers that have reasonably clear goal and clear research questions, and they kind of answer the question, right? So how would you distinguish a good paper from a bad paper? You can read it and then you will know, but you know, reading a paper is often like 1 or 2 hours undertaking. And if you have, I don't know, you did some initial search and you have like 200 potential things to check, you know, that's 200 hours at minimum. That's not a good strategy, right? So how would you narrow it down? How would you filter it?
The abstract.
Results and contributions.
Exactly. So you can read all the abstracts, but even that might be might take time. So what you usually want to do is you want to filter it and order it even before you start reading the abstracts, right? Okay, so let's just read the titles. That will already help you, right? Reading the titles will help you, and some titles are better than others. And, you know, yeah, there is a limit to how much you can get from the title, but that's already good. You can use the amount of citations a paper has, right? So if something has 1 citation or 0, and something has 4,000 citations, you can use Google Scholar or Web of Science to know that. You know, okay, I probably should prioritize the highly cited things because a lot of people have read it, have used it, and they are citing it, which means it was probably useful for them, right? It doesn't mean the 0 cited stuff is not worth reading. It may be worth reading. It's just that if you have to prioritize when you will get to it, you know, you may get to it later, right? You may not get to it in the first round. So check the titles, check the keywords, check the citation counts, and then check the authors, right? So sometimes you will notice that a particular person works in the field of your interest and they have multiple publications. Then maybe you should check them, right? So if you can identify some key names or key people who have published books or papers in that area, you probably should prioritize them as well. So if you use those 3 criteria, then you have kind of an ordered list, and then you start by reading the abstracts, right? After you've read the abstracts or scanned the abstracts, you have a subset of what is potentially worth reading, right? How big that should be, it depends. It depends on the topic you're doing. As we were discussing last week, if the topic is very specific, probably less is better. If the topic is a little bit more general and it can be viewed from different perspectives, you probably need to read a little bit more. Having said that, for the specific topics, you actually have to find those kind of gold papers, those, you know, nuggets that are exactly what you are looking for. And that is not easy neither. You may need to read multiple papers and then say, oh yeah, it was kind of okay, but it was not super relevant, right? It happens that I sometimes start reading a paper and I don't finish it, right? So I understand enough that I know it's not relevant for what I'm doing right now. I can read it later, but it's not what I'm looking for. Even though the abstract looked kind of tempting, it turns out that it's not at the level or at the topic that I'm exactly looking for. Then you stop, right? You don't read the whole paper. You cannot do that. You cannot read everything. You have a limited amount of time during the day, and you can only do so much. And you're taking notes. So while you're reading, you're taking notes. What are you noting? You're noting the author of what was useful for you. You're noting the ideas or the questions they were answering or postulating. And you're noting the references they are making. So who do they build their work on, right? So sometimes we have a choice. We have some paper that is using something interesting for us, but they are just adding small extension to somebody else's work, which was the groundwork for this piece of work, right? And you have to ask yourself, am I really using that extension or am I really using the fundamental work? Because if you're really building on top of the fundamental work, then you cite the original author. You don't cite this extension, right? But you will get to the original work by following those links. So usually people write something or discover something or build something on top of other people's work, and you need to know what those other people's are. So you take those notes. I often take also copy and paste some paragraphs that are kind of spot on descriptions of a problem or a solution or why something is, and you need to explain it later in your thesis or in your report, but here you have it kind of already kind of nailed, right? So then in your report, you can quote the person or you can paraphrase it, depends. Like what is more useful, right? If you want exact definition, you can say according to this guy definition, and then you quote it. Or if you say you want to say the same thing but not exactly, then you can paraphrase it, which is okay as well. So, and I do copy and paste, because if I took notes by paraphrasing it, I may lose some, I may lose some context or some details that later on turned out to be kind of crucial, right? So I usually try to kind of get as accurate recording as possible. So once you've done that, once you've read some things and taken some notes, then you're in a kind of good position to start writing, right? You can start planning your argument. What are your assumptions? What you need to base your work on? What is that you don't know? You have to try, you have to investigate. And what do you think you should get as an answer, as a result? And then you're asking, okay, will I get to this answer by some arguments, by some evidence that I collect? Or how do I convince the reader that that's actually scientific answer? And how it potentially be falsified, right? So can the researchers replicate my way of thinking or way of working or way of measuring something, that they can repeat the experiments and get to the same conclusions, right? Sometimes it's difficult to do that, but we're trying to do that. We're trying to explain in enough details and give the source code to stuff and so on, so then somebody else can independently repeat it and confirm it, right? All right, so it's 3:10. I have to go to, I have meetings with master students, 3:15. So we will finish here. I will expect you to write the paragraphs in the Blackboard. And now try, apart from the paragraph, try to add at the bottom some formulations of questions that you think might be suitable for the work that you're planning, right? They may be just examples of questions. You don't have to commit to any of the questions, and they might be something that is not focused on a single thing. It can be like, okay, this could be a question, this could be a question, and so on, right? In different directions. The only requirement is that those are your questions. So don't cite somebody else's questions. You can do that in the paragraph, but at the bottom, like add some of the questions that you think could be asked. And what we will do next week, we will discuss those questions and see how other people feel, how specific they are, how answerable they are, whether they are good or bad kind of research questions from those criteria that we discussed today. All right, so we'll have a discussion on those questions.
But it's only for those who are planning to write an article, right?
This is for those who are who are planning to write an article. But for those who want to explore the technology, you will also have some questions that you will answer by not by writing, but by measuring or building something, right? So it applies to those people as well. So in your case, you should have something in mind of why you're building it, what do you want to test, right?
Okay.
Yeah.
And what about like, is it only for the mobile part, or is the same work for game technology? Because I actually mine the two aspects are related. Like what I will build will give me some questions, but those questions are more related to the game aspect than the mobile aspect. So
then use it. I mean, that's okay, right?
Oh, okay.
So yeah. So that there is no need to distinguish between those two courses in your case when you're doing kind of similar work. You're doing a body of work for both courses, and you will end up with two technical reports, right, and a single artifact. It's okay if you formulate the questions from the game aspects for now. Yeah. Okay.
And the hand-in deadline, there seems to suddenly be a hand-in deadline on Student Web in October.
Yes, so the students noticed that last week as well.
Yeah.
So disregard that one.
Okay.
We will have a hand-in deadline probably sometime in November or maybe end of October after you've done all the presentations. So there will be a hand-in kind of 2 weeks before the exam, I would say. So I don't know, we haven't decided when to have the exam. The exam is oral, so it's up to us to decide that. But the hand-in will be about 2 weeks before the exam. So I would say probably mid-November, actually.
Yeah.
It depends when we want to finish, because once we have the exam, then nobody needs to worry about anything anymore, right? So we may decide, okay, let's do exam, I don't know, mid-November. So then the hand-in will be like beginning of November. But if we say, let's not rush, let's have the exam, late in November or early December, then we push it. I'm flexible. So as usual with the oral exams, it's like we arrange it towards the end of the course, and
Everything will be in the discussion.
yeah, so everything will be on the Blackboard, and we coordinate with Simon because of the game similar. There is also oral exam, and we kind of need to allocate the whole day for running the exam. So yeah, okay, cool. So thank you very much, and I will see you next week on 9 o'clock in Tuesday. So there is no more confusions. Yeah, game lab.
So there's still the game one on Thursday? Is it,
Yes. Yes, until Simon says.
Until it
Sorry.
says that it's on
Yep.
Thursday.
I haven't wrote anything in discussion board
Okay.
because I would say